All right, hello everyone. So now that we've gone through all that work to get our p-value, it's 0.318. All that is so we can make a conclusion that's kind of interpretable to someone who might be interested in this study that we did. And so we're actually going to skip the bottom of page 7. Again, we will come back to that, the top of page 8 as well. We'll come back to that also. We just want to jump straight into the most important thing, which is writing this conclusion using a scale of strength of evidence. And so our p-value is 0.318. We, in general, most would say that that's really not quite low enough to indicate that there's any real evidence that there was random guessing, or that there was something other than random guessing, excuse me. So we're going to wind up using this kind of scale thingy. And so this is going to represent different values that our p-value can take. And most people would agree that if your p-value is less than 0.01, here we're going to write how much evidence for the alternative there is. So if our p-value is less than 0.00 or less than 0.01, this would be considered strong or convincing evidence for our alternative hypothesis. Let's try to think about this logically. And so I'm going to go back to page 6 and look at our sampling distribution. For our p-values less than 0.01, then that means that our sample proportion is somewhere kind of in the tail, so like either way over here or way over here. This was drawn assuming the null hypothesis is true. And so if the p-value is in, or if our sample proportion is in that tail, it's going to give us a small p-value. That's going to tell us that, well, okay, maybe our assumption that the null hypothesis is true when we drew this distribution, maybe that's not quite right. And so that's going to give us some evidence for our alternative hypothesis, that the proportion is different than a third. We won't go back and forth, but the same logic kind of holds for these other ranges. So if our p-value is between 0.01 and 0.05, we're going to kind of say that that's moderate evidence for our alternative hypothesis. If it's between 0.05 and 0.1, then that's kind of weak or just kind of marginal evidence. So there's like a tiny bit of evidence for our alternative hypothesis, but it's not too much. And if it's bigger than 0.1, then we're just going to say flat out, this is kind of universal. So if you're kind of reading studies in like a biology journal or whatever journal, the p-value is bigger than 0.1, then that's no evidence that the alternative hypothesis, no evidence for the alternative hypothesis. And so our general kind of template for the conclusion that we want to write is we want to first state what your point estimate is in context of the problem. And so we want the reader to kind of know what our best guess is for the proportion of students who answered that question right. That seems like really relevant information. We also want to say how much evidence there is for our alternative hypothesis, or how much evidence there is that the proportion is different than a third, or how much evidence there is that there was kind of this non-random guessing happening. And so we want to say there is some adjective that we're grabbing from up here based on what our p-value is, evidence for the alternative hypothesis, but we want to write that in context of the problem. And then we want to give what our z-stat was, and we want to give what our p-value is. so that the reader has all this information that they could kind of use in their own judgment of whatever study's happening. For example, we might say we estimate that the proportion of all SLU students who answer the gender school question correctly is 0.27. That's our best guess for for the proportion of students that are going to answer that question correctly. There is no evidence. So remember, our p-value was 0.3 something, so that's up here. So that's the no evidence part. That the proportion of SLU students who answer the question correctly is different than a third. So where did that come from? That came all the way back from our alternative hypothesis. All I'm doing is writing this in context of the problem. So p not equal to 1/3 in context of this problem translates to the proportion who answer the question correctly is different or not equal to 1/3. The last two parts are pretty easy since we've already, or easy after you've calculated them. Our z stat and our p-value, which was 0.318. All right. So again, I know this probably seems like a lot, but we've written this general template in this way, so we're being really careful. We want to kind of nicely set ourselves up for the rest of the semester when we do all this hypothesis testing to kind of have this to reference over and over again so that we kind of can get into a routine of making conclusions. And the more we do, kind of the more sense that this process will make. So, as always, let me know if you have any questions, but definitely do keep in mind that in class we will see 2 other examples. We'll pretty much spend the entire class letting you all kind of practice with those 2 other examples, the steps that we've completed in these last few videos.